Have you ever seen a fluid that acts as a solid? Well, if you have seen a non-Newtonian fluid in action. Today we're going to be making a non-Newtonian fluid and we're going to play around with it. As always, let's gather our materials. We're going to need a bowl filled with water, which is about a cup of water. We're going to need a spoon, some cornstarch, something to measure with. I'm going to use a mason jar, and some food coloring. Now I'm going to choose red coloring, but you can choose whatever color you'd like. Let's start with our bowl of water. And what we need to do is take our food coloring and we're going to drop several drops of it into our water. Ooh, look at that color. So red. Let's give this a little stir. Make sure it's all mixed up really good. We're gonna take our cornstarch, about a cup and a half, and we're gonna mix it into the water. Now you grab your spoon and start from the bottom and start mixing it around. Make sure you get all the little lumps in there. Some of it will stick to the bottom. It's not getting to the consistency that I want it, so what we're gonna do is continue to add some cornstarch until it starts getting a thicker consistency. Ooh, now it's starting to get thick. Wow. Make sure you keep stirring it. If you look at it, it's real liquidy, but it's also a solid as I go through it. So now what we're gonna do is we're gonna give it a punch because it's not supposed to let me touch the bottom of the liquid. Whoa. Wow, and it didn't even splash. It stops my hand from touching the bottom of the bowl. Wow, not much of it got on my hand. Now, why did that happen? There are two key concepts at play here: viscosity and pressure. So we know that we can change solids and liquids by using heat and cold. We can turn water into ice by putting it in the freezer, and we can turn water into steam by boiling it. But did you know that pressure instead of temperature can cause some changes in properties of some materials? An everyday example of this is, have you ever tried to boil water at different altitudes? If you boil water at a low altitude or close to the sea level, it'll take you a while to boil it. However, if you're up in the mountains, the water will boil much faster. This is because of the pressure difference. At a high altitude, the pressure is lower, which makes the boiling point lower. We also need to talk about viscosity. Viscosity is how thick something's consistency is. Water does not have a lot of viscosity. It flows and goes all over the place, and it's not very sticky. Honey, however, does have a lot of viscosity. It oozes around, and it's very sticky. So what's happening to our mixture? We've already noticed that when we increase the pressure on our mixture by smacking it, it becomes more viscous like honey. However, when it's not under pressure, it's less viscous like water. This is a great example of a non-Newtonian fluid. We can see for ourselves that it has very different properties under different pressures. Whoa! You see that? That's pretty cool! We need a third cup of water. We need some vegetable oil. We need some Alka-Seltzer and some food coloring. Now I'm gonna choose blue instead of any other color, but you can choose whatever you'd like. Now that we have our water, which is about a third of the way full, I'm gonna add some food coloring into it. We're gonna do about 3 or 4 drops. It doesn't really have to be exact, but it's nice to put some in because you can see the colors. Now, I'm gonna fill the rest of the cup with some vegetable oil. Here we go. About right there. And the next thing we're gonna do is we're gonna take our Alka-Seltzer. Now you can just break it in pieces or you can put it in just like it is. Here we go. So I'm gonna break mine into little pieces. See how it's bubbling up? Whoa! You see that? That's pretty cool. why did that happen? Did you see how the carbon dioxide bubbles are being released from the seltzer tub and pushing the water molecules up? How cool is that? If you pay close attention, you'll notice that the water molecules, once they make it all the way up to the top, they fall right back down due to their density, and the cycle continues. Now, if you don't have Alka-Seltzer on hand, you can just put a lid on it and then give it a little shake, and it'll do the same thing. I hope you enjoyed this video and you'll go and make your own lava lamps out there. So join us next time for a new experiment on Expulsion Science. Uh-oh, can I get a paper towel? Yeah. Because some of it spilled on my hand. I'm bleeding, yeah. No, I'm kidding. Oh man, they caught me red-fingered. I'm making Pepto-Bismol. Just kidding.